Welcome to RGES Algebra 1. This is lesson 33B. I'm Mrs. Kinzer, and we are going to do today our Chapter 7 review in preparation for the final exam. Now, before we begin, I'd like to read Psalm 103, verses 1 through 5. It says, "Bless the Lord, O my soul, and all that is within me, bless his holy name. Bless the Lord, O my soul, and forget not all his benefits, who forgives all your iniquities, who heals all your diseases, who redeems your life from destruction, who crowns you with loving kindness and tender mercies, who satisfies your mouth with good things, so that your youth is renewed like the eagles." And so the exhortation, the bottom line exhortation here is that we would bless the Lord, that we would declare his glory, his goodness, his kindness, his faithfulness, that we would do it with all our hearts. It says, all that is within me, wholehearted gratitude before the Lord. It goes on and declares what I think is the key to being able to have a wholehearted gratitude towards the Lord, and that is that we do not forget. Don't forget his benefits. Do not forget what he has done. Do not forget who he is. Do not forget how he has cared for you. Do not forget how he has protected you. Do not forget, etc., etc. You fill in the blanks. We are to remember. Remember your God. Now, he gives us this exhortation, David does, because he recognizes that it is easy in the noise of life and the pain of life and the challenges of life and even just the busyness of life, it is easy to forget our God. So he's saying, stop. Remember your God. Remember who he is. Remember his character. Remember his goodness. Remember all the answers, all the times you have cried out to him and he has been there. Remember your God. He writes a story in each of our lives, and one of our greatest weaknesses is that we so easily forget what he has done. He gives us examples. Don't you remember when he forgave you? Don't you remember a time recently where you have done what is wrong, where you've recognized your sin, you've recognized your pride, you've recognized your selfishness, you've recognized your hypocrisy. He has shown you, and you've asked forgiveness, and he forgives you. Don't you remember when he healed you, touched your body, gave you strength again, when you weren't sure you were going to recover? Don't you remember when he revealed his Son to you and brought you into life when you thought you were dead and remade you from the inside out? Don't you remember his kindness to you in this situation or in that, when you were in need and you cried out to his name, when he brought the peace, the provision, whatever you needed? Where do you think that sense of love that he pours out, the mercy that he pours out, where do you think that sense of well-being in your spirit comes from? Where do you think the provision for every little thing and every large thing, where do you think it comes from? The strength to continually be renewed, it says, so that your youth is renewed like the eagles, that he continually gives you the strength you need for each day. Where do you think it all comes from? pause, and bless the Lord. Well, in this chapter, chapter 7, we're going to review in preparation for your final exam, and it has lots of ideas on it, but the overarching idea is that we are working on simultaneous equations, systems of equations. Now, what does that mean? It means that I might have one equation with an x and a y, and I might have a second equation with an x and a y. And I want to know what value, if there is any, that has a value for x, what combination, what pair, value for x and value for y would make both this statement true and this statement true. Is there a number here and a number there that would make both these statements true? Now, visually, what is represented by that is if you have line 1 and line 2, and they intersect each other at a point, and that point, it's a certain value of x and a certain value of y, such that if it lies on line 1 and it also lies on line 2, it's that point right there. So, now, it could, I say, if there is one, could you imagine one way that there is not a point? Well, if line 1 were like this, and line 2 were parallel to it like this, there would be no solution. There would be no single point that lies on both these lines. The other way there's no solution is if line 1 were like this, and line 2 were the same line. There would be no one point that would lie on both these lines. In fact, there's an infinite number of points that lies on both those lines, right? So there would be an infinite number of solutions. So that's the background. We're looking at lines. We could even just say solve it by graphing and read off the point. But that's laborious because it's hard to be accurate to read off that point exactly unless the equations are kind of fabricated so that they're easy to read off a graph. Okay. So now, the next idea that's a prelude to that is how do I deal with a expression? Okay. Let's say I say 3x minus 2y. That's an expression. And I could say evaluate this expression, but I would need to have two values. I could say evaluate it if x equals 3 and y equals 0. So I would plug in, every time I see an x, I'd plug in a 3, or I'd put the value 3 in. Every time I see a y, I put the value 0 in. And what would x equal? Well, 3x, or what would this whole expression equal? I'm sorry, shouldn't say what. Okay, the whole expression would equal 3 times 3. I should have put a y there. Minus 2 times 0. This is 0. So, and 3 times 3 is 9. So the value of the expression would be 9. That's one kind of way I can ask you to deal with or provide some kind of information when I give you an expression. Now, here's another way. Let's say I had 3x minus 2y, and I say evaluate that if the expression equals 12 and x equals negative 2. That means I want to set so this is the second way I can deal with this. I want to set the whole expression equal to 12, and every time I see an x, I want that to equal -2. So I'm plugging in the value of the whole expression, so I'm giving it an equal sign now, or the value of the x. -6 minus 2y equals 12. I would take that to the right-hand side by adding it. 12 plus 6 is 18. I would divide the opposite of multiply. This is multiply by -2. So I would divide by -2. And y equals -9. So I would say to you, find y if the expression equals 12 and x equals -2. Could you imagine what the third possibility would be? I could say evaluate. Yeah, I'll say it this way. I'll say find x if the value of the expression equals 4 and y equals -1. So now what would you do? You would take the whole expression. You would say 3x minus 2y equals 4. That's the value of the expression equals 4. And for every y, I would plug in -1. Then go ahead and evaluate that. And we would just do the same thing we did when we solved for y earlier. We'd plug in and we'd keep simplifying until we had the only variable left, the x variable, solved for. Now the next major idea we want to review is this idea of how to understand the formula for a line. And there are two formulas. There's actually more, but these are the two we're asking you to know. The first one is called the slope-intercept form, and you will want to know this. And when we say intercept, we mean y-intercept. We just call it the slope-intercept form, but it's the y-intercept. And that is y equals mx plus b. You want to memorize that, and you want to know its title. So in this, the x and the y represent a point. M represents the slope, and b represents the y-intercept. The second form is called I'm not sure that got covered actually for you, but it's called the point slope form. So I guess we'll do that more in Algebra 2, the point slope form. So ignore that right now. Okay, so let's go back then to the slope intercept form of the equation. If I say, let's say y equals -3/2 x plus 2. What does that tell me? This is the slope of the line, and this is where it crosses the y-axis. So how do I deal with that? Well, I'm going to cross it at the y-axis. This is the y-axis, remember, at positive 2. So that's the first point right there. I only need 2 points to define a line. So where's the second point? Would it be up here, down here, over here? How do I know? Well, I'm going to move at a slope. Okay. And my slope will take me, now let's look at slope. Slope is defined by m, that's the variable we use to mean slope. It is the change of y, the difference in the y, or how much I want to move in the vertical direction, that's vertical, and how much I want to move in the horizontal direction, because this is the x-axis, the horizontal direction. So I'm saying I want to go the vertical direction -3 and the horizontal direction 2, because the horizontal direction is by the bottom number and the vertical direction is by the top number. Now, because it's negative, I want to go down. If it's positive, I would want to go up. So move in the vertical direction from that first point, move down 1, 2, 3 to here, and move right. Always move your horizontal direction to the right, and either move up or down. Okay. And that would go 1, 2. So my next point is right there, and then I can draw a line. Now I'm going to draw several more lines with you using the slope-intercept form of a line. If I have the equation of a line here, and I tell you graph it for me. Okay. I could tell you 3 things here. I could say, what is the slope? Put it in fractional form, -3/1. I could just say -3, it's okay. But you want to think about it as -3/1 when you start graphing it. What is the y-intercept? 4. And how would I graph it? I'd start with the 4. On the y-axis, go up to 4. Go down 3 and right 1. There's your second point, and draw a line through them. Let's look at the next one. What is my m? What is my b? That's my y-intercept. And how do I graph it? On the y-axis, which is what b is, on the y-axis, go down -2 and put your point. Go up, because it's positive, 1. Go right 3. Let's try that a little easier. 1, 2, 3. There's my second point, and draw a line. So make sure you know how to do that. I'm going to give you equations, and you need to know, not only do you have to do that evaluating, we showed you before, but you need to know what, if I give you the equation of the line, you need to tell me what the slope is, what the y-intercept is, and be able to graph it. Now, what if I give you the equation of the line instead by saying 3x minus 2y equals 9? And I said to you, what is the m, what is the b, and graph it. Okay. Well, if I ask for m and b, put this as y equals. So solve for y. -3x plus 9. y equals, divide by negative 2, divide 9 by negative 2. Okay, this is m, this is b. That's also would be equal to negative 4 1/2. That's going to be useful to me. Okay. And when I graph it, this is my y-axis, this is my x-axis. I'm going to go down to negative 4 1/2. 1, 2, 3, 4. That would be 5, so this is 4 1/2. Then I'm going to go up 3 and right 2. So up 1, 2, 3, right 1, 2, and my next point would be there. Just like that. Now there's a second way I can think about when I want to graph. If I don't ask you to give me the slope and the y-intercept, but instead I say give me the x-intercept and the y-intercept, you could also think about it this way. The x-intercept means where it crosses the x-axis. Now think of a graph with me for a minute. If I have a line where it crosses the x-axis, what is the value of y? Where it crosses the x-axis, what is the value of y here? It would have to be 0. Where it crosses the y-axis, what is the value of x here? I'm plotting 0 something, right? Remember that for this idea. So when I want to know the x-intercept, put a 0 in for y. That means the same way as you can interpret that as you can say, what does x equal? If I say, what is the x-intercept? I say, what does x equal when y equals 0? That's another way to look at this. If I'm asking for the y-intercept, I'm saying, what does y equal when x equals 0? Okay, so let's go back to my equation. What's the x-intercept? Well, when I want to know the value of the x-intercept, I'm saying, what does x equal when y equals 0? Well, if y equals 0, 4 times y also equals 0. So 3x equals 36, and x equals 12. The point would be 12, 0. But I could also say just x-intercept equals 12. That's fine. I'll accept either one. What is the y-intercept? I want to know what the y equals. So let's go back here. What's the y-intercept when x equals 0? Well, if x equals 0, then 3x also equals 0. And I would end up with 4y equals 36, divide, and y equals 9. Perfectly good answer. I could say y-intercept equals 9, or I could say the y value in a point is 9. Remember, this is the y value, this is the x value, and this would be 0. Either answer is good. So how would I graph that if I'm working in that direction? Well, the line I want to graph crosses the x-axis at 12. So let's go over on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Crosses the x-axis or the y-axis at 9. It's also positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's all you do to graph it. Let me do another one for you quickly. Let's say I give you the equation of a line. I say, what is the x-intercept? What is the y-intercept? And graph. The x-intercept is what is the x value when y equals 0. So I would think 9x equals 18 or x equals 2. That's the x-intercept. Let's go back. For the y-intercept, I would think, what is the y value? Whoops. What is the y value when x equals 0? Well, if x equals 0, 9 times x equals 0, and I would have negative 3y equals 18 divided by negative 3, and y equals negative 18 divided by 3, or 6. So that's the y-intercept. How would I graph it? I have my y-axis, my x-axis. On my y-axis, I want to go over 2 and plop a point. On my x-axis, I want to go down from the origin, 6, and plop the second point. And that's how you graph it. Now let me see what else we need to talk about. What do I do in these these are special cases. One is going to be horizontal and one is going to be vertical. Which is which? Well, if I draw my Cartesian coordinate system with my y-axis and my x-axis, plot on the x-axis negative 3. Okay. I want that point on the line. I also want x always to equal negative 3. So here it equals negative 3, here it equals negative 3, here the x-axis, the x point also equals negative 3. What is changing? The y is changing. So this one is a vertical line. Go crossing through x equals negative 3. When I plot y equals 4, I go up on the y-axis to 4, and I want the y to always equal 4. Well, it equals 4 at that point. Where else does it equal 4? Well, this would be 1, 4, right? 2, 4, negative 1, 4. Y's always equal 4 when I'm going this way. Does that make sense to you? So this is a horizontal axis, or a horizontal line. So go ahead and study that. Make sure you knew that. Now, the next idea is when I have two equations, I can solve without graphing and trying to find the point of intersection two ways. I can solve by substitution, and I can solve by linear combination. Let's do the first one. Let's say I have y equals negative 2x and 3x minus 4y equals 9. To solve for where my y and my x are, I would take, if I already have one equation, one of the equations solved already for x or y, this would be a good way to solve it by substitution. Or if I tell you to solve by substitution, first get one of the equations in the form where either x or y is by itself. So if y is by itself, and I say y equals negative x, in the next equation, every time I see a y, I'll plug in negative 2x. So then you get 3x minus 4 times negative 2x equals 9. Solve. This is a multiply because you have the number, the constant, right next to a parenthesis. That means multiply. So we'll have 3x. Negative times a negative is a positive. 4 times 2 is 8. Combine 3 and 8 more x's will give me 11x. Divide, and x equals 9/11. So what's my solution? For my x value, remember you're always solving for a point, the point of intersection. It's 9/11. For the y value, I would go back to here. Y equals negative 2 times the x value, which is 9/11. Let's 11ths. There we go. Okay, so this would be y equals negative 18/11. That cannot be simplified, so that's a great answer. Be hard to graph. Why am I having trouble with my 11s? There we go. Hard to graph, but a great solution. That's called solving by substitution. The other one, remember this is just a review, is let's say if I had something like 3x plus 2y equals 9 and 7x minus 2y equals 12. The key here is that both in one variable, either the x or the y, we have the same constant and opposite signs. If you don't have that already, you can manipulate your equation. You can shift your equation to make that. Okay, but this is great because it already has it. I'll show you one where I'm making it happen in a minute. So this is called solve by linear combination. Now, I would suggest that if this is not very familiar with you, not only would you go back to your quizzes and your tests regarding Chapter 7, but also go back to the tapes with sections on Chapter 7. But here, you would add straight down. When I'm adding my x values, 3x plus 7x is 10x. When I'm adding my y values, plus 2x minus 2x is 0. And that's what I want. I want one of my variables to drop out. So I only have one variable, because that's easy to solve for one variable. Right? And when I'm adding my numbers on the right, 9 plus 12 is 21. Divide, and x equals 21x. No, x equals 21 over 10. There we go. Now, how would I figure out my y? Then I would have to go back, take either the first equation or the second one, plug in for the x, all kinds of ways I can do this. Depends on what you're comfortable with. I could just take away my denominator by multiplying everything by 10. Don't forget it's all three terms by 10. And the 10s will drop out. I get 3, that's 6, 3 times 21 is 63, plus 2y. Whoops, don't do that. Mrs. Kinzer, you have to multiply every term. Okay, I multiplied that one, multiply the next one by 10, 20y. Multiply the next one by 10. Mrs. Kinzer sometimes forgets that. on this, so I'm trying to do things to help me remember. You're free to do things to help you remember also. Subtract 63 from the other side, and you're going to get 3027, divide by 20, and that does not simplify, and that would be my answer for my y. Remember, when we're solving systems of equations, we always need an answer or a constant. We need to solve for both x and y. Now, there is one other idea here, and I will show you another solving for linear combination, where you have to manipulate it to get it to that point. So let's say instead I had, let's say 2x minus 7y equals 9, and let's say 5x minus 3y, or plus 3y equals 4. There we go. Okay. So I need a common number here. So if I multiply the first equation by positive 5, I'd get a 10x. And if I multiply the second equation by negative 2, I'd get a negative 10x. So let's do that. Then I would get 10x minus 35y equals 45. And on for the second equation, I get negative 10x minus 6y equals negative 8. Now when I go, these satisfy what I need. This will drop out, adding as you go straight down. Minus 35 minus 6 is minus 41y. Minus 41y. Go straight down, that'd be 37, and divide. They're not coming out very even because Mrs. Kinzer is making these numbers up off the top of my head. Rather than putting the negative in the denominator, you typically put it in the numerator. Okay, and that's halfway, and then what would I do? I'd pick one of these two, plug it back in, just like we did before. So the numbers you are going to get are probably, or the equations are probably not going to be that complex, but that's the method of how to do it. Now, the only other thing I can say regarding chapter 7 is that we will also have word problems. Word problems in this unit tend to be things that let's say, maybe I would have tickets, the number of tickets and the price of the tickets. That gives me two equations. If I sold, for instance, something like this, if I sold balcony seats and regular seats, and I sold 7, or let's say I sold 700 in all, and these were twice, the other way. Balcony seats cost twice as much. My first equation would be 2x plus y equals 700. See that? These would be balcony seats, these would be x's. Actually, sorry, let me think a little harder. I'm making this up off my head. Okay, it can be simpler than that. I could say all my balcony seats together, the number of balcony plus regular seats altogether is 700. Okay, balcony seats cost twice as much as regular seats. So if they cost X, these cost twice X. I'm doing the same mistake. Back up. I'm sorry. It's easier than I'm making it. Sorry. Let's do it this way. Let me read it to you. Okay. Third time's a charm. Let me read you a problem. Reserved seats cost $4 and general admission seats cost $3. the game sold 1,787 tickets and took in $5,000. Let's simplify. Okay, reserved costs $4. General costs $3. We sold 700 tickets and we made $1,250, let's say. That's probably not very good math, but that's all right. All I want to do is show you the way for your first equation would relate to the number of tickets. Do I know how many regular tickets versus reserve tickets versus general admission? No, but I would just say R plus G, but I know how many I sold altogether. That's my equation number 1. My equation number 2 relates to money. Do I know the price of my reserved tickets? Yes, $4 for every one. Do I know the price of my general? Yes, $3 for every one. And how much money did I make? $1,250. Now, if I solve this, maybe I wouldn't like the numbers, but that's all right. That's the idea, okay? So word problems in this section relate to being able to get 2 equations. 1 equation, 2 equations related to what I care about, reserved and general. Okay. One way to do that is when we think in terms of the amount and the price. Okay. So review some of those also. So we're going to stop right here and make sure that you continue your review on this chapter today, or before you get to